So, good afternoon, all. Today I'll be starting with third module. Third module is about IP as a IoT network layer. Okay, so actually in this chapter we will be discussing network transport layer, which is sub layer that is part of communication network layer, which we studied under core IoT functional stack, which is one of the simplified IoT architecture, right? Wherein we studied, just a brief description was given about this particular layer. So we are going to see this layer in detail in this chapter. Okay, so we will be discussing network transport layer, which is a sub layer that is a part of communication network layer under the architecture core IoT functional stack. Fine. So in this chapter, we will be discussing four sections. The first one is the business case for IP, that is Internet Protocol. Next topic, the need for optimization with respect to Internet Protocol. Third one, optimizing Internet Protocol for Internet of Things. And the last one, profiles and compliances. So under the business case for IP, we will be discussing the advantages of IP with respect to IoT. Okay, and we are going to adopt or include the concepts of adoption and adaptation with respect to Internet Protocol. Okay, next, under need for optimization, the challenges with respect to constraint nodes and the constraint network will be discussed. So wherein IP protocol, with respect to IP protocol, we will be discussing this. Okay, and then under optimizing Internet Protocol, which is used for IoT, here we'll discuss a few Internet protocols. Along with the Internet protocols, we will discuss 6 LoWPAN and then RPL protocols. Okay, so and that means in this optimizing IP for IoT, we will be discussing few protocols which works along with the Internet protocol. Okay, the last one, as I said, profiles and compliance. Here we'll see the significant organization and the standard borders which are involved with IP, that is Internet protocol, connectivity, and Internet of Things. Okay, so these are the topics we will be discussing in this chapter. Okay, as the first topic with respect to this chapter is the business case for IP, that is Internet protocol. So before starting that, just want to convey this statement, that is the protocol stack and the extended conversation to the network layer connectivity, which is commonly referred as a layer 3. So we will be discussing about layer 3 under which is that network transport layer. Okay, so the first thing is, as I said, the business case for IP, that is Internet protocol, right? So see, in the last chapter or till this, till the last module, we know that data flows from or to the IoT things, or you can say devices, right? Where data is consumed or controlled or monitored by the data center servers. Either it may be in the cloud or in location that may be distributed or centralized, right? So for all this, for the data transferred or the control, we know that Internet protocol will play a important role, right? It play a key architectural role since from many years, right? So we'll see the advantages with respect to this Internet protocol. So here, once we study the advantages of Internet protocol, we'll see the concept introduced with respect to this, that is adoption and the adaptation. The key advantages of Internet protocol are listed here. The first one is open and standard based. Okay, so here operational technologies like OT, okay, which which have often been delivered as a turnkey features for vendors, right? Who may have optimized the communications through closed and the proprietary networking solution. Or you can understand in a simpler manner, that is the Internet of Things, that is IoT, creates a new paradigm in which devices, applications, and users can leverage a large set of devices and the functionalities while guaranteeing interchangeability and interoperability, security, and the management. Okay, so this is with respect to open and the standard based. Fine. So here, uh, the body called Internet Engineering Task Force. Okay, this will give you what are the open and the standard based operation technologies used for the Internet protocol. Fine. And the next one is versatile. See here, a large spectrum of access technology is available for the connectivity of things. We saw in the last chapter, right? Many access technologies are available to connect the things which are involved in the IoT, right? And additional protocols and the technologies are also used to transport IoT data through backhaul links and in the data center, right? So all this also we discussed in the last class, see, in the last chapter. Okay, so here, the layered IP architecture, as well as I layered IP architecture is well equipped to cope with any type of physical and data link layers. Okay, and next advantage is ubiquitous, where it says all recent operating system releases, from general purpose computers and the servers to lightweight embedded systems, have an integrated dual IP stack, that is IPv4 and IPv6, that gets enhanced over time. That means you consider any what systems or embedded systems, okay, which includes IPv4 and IPv6, right? So, in addition to this, IoT application protocols in many industrial OT, that is operational technology solution, have been updated in recent years to run over IP, right? See, many protocols are updated so that to work with Internet protocol, right? And next advantage is scalable. As we all know, IP has been massively developed and tested for robust scalability, right? See, millions of private and public IP infrastructure nodes have been operational for years, offering strong foundations for those not familiar with IP network management. That means Internet protocol supports the scalable of many devices, right? And it's one of the strength as well, right? And the next one is manageable and highly secure. See, this advantage says communication infrastructure that is followed requires appropriate management and security capabilities for proper operations. That is, this Internet protocol will have appropriate management and security capabilities for the proper operation. Okay, and one more thing is adopting IP network management also brings an operational business application to operational technologies. That is one more thing. Next advantage is stable and resilient, uh, where we know that since 30 years, Internet protocol acts as a solution for many problems, right? So this IP has been deployed for many critical services like voice, video, and many other services, right? And which have already transitioned from closed environment to open IP standard. Fine. And the next one is consumers market adoption. So here, when developing IoT solution and products, targeting, which obviously it targets the consumer market, right? Which targets consumer market, Vendors know that consumers' access to the application and devices will occur predominantly over broadband and mobile wireless infrastructure. Okay, that is one more advantages. And the last one is innovation, the innovation factor, that is IP, that is Internet Protocol, which is used for the application which are ranging from the file transfer, email to the World Wide Web, e-commerce, social networking, mobility, and many more. We know that all these application works on Internet Protocol. So these are the advantages of Internet Protocol. Okay, which leads to a business. I mean, which helps in growing the business sector. Okay. Next, see, the adoption of IP provides solid foundation for the Internet of Things because of its advantages by allowing secure and manageable bidirectional data communication capabilities between all devices in a network. So this is with respect to internet protocols. So with respect to internet protocol, you already knew many things, right? You have studied in data communication as well as in CN, right? So all together they have summarized and they have presented here how it is helpful or how it is being used in the internet of things. Okay, and next, as I said, these two concepts are included in the internet protocol, that is adoption or the adaptation. So one of two module, two modules are discussed here. First one is adaptation, which means application layered gateways, in short it is called as ALGs, must be implemented to ensure translation between non-IP and IP layers. Okay, this adaptation must be implemented to ensure the translation between non-IP and IP layers. And next one, adoption. This involves replacing all non-IP layers with their IP layer counterparts, simplifying the deployment model and the operations. So these two models are included in the Internet Protocol so that it works better in IoT. Okay. Next, topic, as I said, is need for optimization. Okay, so here, why optimization of Internet Protocol is required? That we will be discussing here. Okay, so optimization are needed at various layers of IP stack to handle the restrictions that are present in the IoT networks, right? Optimization is required at the different layers of IP stack to handle restrictions that are present in the IoT networks. Okay, so as you know, uh, one second, yeah, it's here. Okay, so Internet Protocol, you know that nowadays IPv4 we are running out of address space, right? So that's why we are moving it into next version, that is IPv6. So this provides lot of space for the IoT devices so that you can address each and every objects in the IoT or the things in the IoT which are connected to the internet, right? So under this, we will be studying first topic as IoT constraint nodes. So we already discussed what is constraint nodes and the constraint network in the in the first module itself. And we know that with respect to IoT, we have different classes of nodes, class 0, class 1, and class 2, right? So all these classes has not implemented IP stack to the full fledged. Okay, only some of the features are implemented in their nodes. Okay, that's why those such nodes are called as constraint nodes. Okay, so with respect to constraint nodes, we note that power consumption is one important characteristics, and we already know IoT devices are battery powered, right? So all the devices or the objects or the things run with the help of battery, right? And this lifetime battery, I mean, few IoT devices may have a battery which runs for a few months, or it may run still 10 plus years or many more years, right? So because of this, I mean, this drives the selection of networking topologies. That is, the power consumption characteristics, power consumption characteristic drives the selection of network topologies, since high speed one like internet or maybe Wi-Fi or the cellular network, so it needs for such devices or the things, you need to have a multi-year battery life. So wherein that is not possible with respect to constraint nodes, right? So here, see many nodes which are deployed in IoT may have a may have a issue with respect to the battery lifetime, right? So in those nodes should work in a low power mode, okay, instead of keeping it all the time on, okay, and or else we can go for off the power, and we have to switch it on only when there is a communication that happens in the IoT. Okay, one thing is low power mode should be switched on, or we have to switch off the power, and only it should be switched on when there is a transfer of data from the particular node. Okay, and this IoT constraint nodes can be classified as follows. The first one is devices that are very constrained in resources may communicate infrequently to transmit a few bytes and may have limited security and management capabilities. So here this drives the need for IP adaptation model where nodes communicate through gateways and the proxies. And the next classification is devices with enough power and capabilities to implement a stripped down IP stack or non-IP stack. Actually, in this case, we need to implement either an optimized IP stack and directly communicate with application servers, that is, adaptation model must be deployed, or go for IP, that is, Internet Protocol or non-IP stack, and communicate through gateways and the proxies. That is, here only adaptation model is followed, whereas here adoption as well as adaptation model need to be followed. And the last classification is devices that are similar to generic PCs in terms of computing and the power resources, but have constrained network capacities such as bandwidth. So these kind of nodes usually implement full IP stack, that is, you can say, adoption model, but network design and the application behavior must cope with the bandwidth constraints. So these are the three classification when it comes to IoT constraint nodes. Okay, so next we have one more subtopic here, that is constraint network. So constraint network is the one, or we can also call it as low power and lossy network, that is LLNS. Okay, so these kind of network have unreliability, because of which the data flow rate may be less, or there may be packet loss also with respect to constrained networks. Okay, so after that we have IP versions. As you know, a particular working group, that is IETF. This group, this group is working on, just a minute. Okay. this group, that is IETF, the Internet Engineering Task Force, that is IETF, which has been working for transitioning the internet from IP version 4 to IP version 6. So we all know that day by day IoT things, that is objects or any things which are present uh, in our environment, are we are trying to connect it to the internet, right? So if we connect any object to the internet, it should have its own address, right? So initially we were using IPv4 address space, which is already running out. So now we are moving it to the IPv6 addressing, isn't it? So here IPv6 has much larger range of addresses, which can be assigned for the objects we are connecting it to the internet. Okay, and here the main driving force has been lack of address space. We know that IPv4 as internet has grown. Next, here we will be discussing the main factors applicable to IPv4 and the IPv6 support in an IT solution. The first one is application protocol. See, in IoT devices implementing Ethernet or Wi-Fi interface can communicate over both IPv4 and IPv6. But the application protocol may dictate the choice of the IP version. Okay, that is about application protocols. And next is next factor is cellular provider and the technology. See, IoT devices with cellular modems are dependent on the generation of cellular technology as well as data services offered by the provider. Okay, that is about cellular provider and the technology. That means IoT devices IoT devices with the cellular modems are dependent on the generation of the cellular networks as well as the data services offered by the provider. See, if you consider first three generations of data services, then that is GPRS, Edge, and the 3G, where IPv4 protocol were used, right? So then uh, on 4G or LTE networks, you know that data services can be used, either it may be IPv4 or IPv6 depending on the provider. And the third factor is serial communication. See, as of now, till date, many legacy devices are in industry, right? Such as like in the manufacturing and utilities, all these fields. All the devices with respect to these fields communicate through serial lines itself. Okay, so when it follows serial lines, data is transferred using either proprietary or standard based protocols, like DNP3, Modbus, etc. Okay, and communicating with the help of serial data over any sort of distance could be handled by analog modem connection. Okay, so that is with respect to the serial communication. And then IPv6 adaptation layer. Since all the devices need to be assigned with the address when it is connected to the internet, obviously now we can't use IPv4, which is already running out with the addresses, right? So that's why we need to include this IPv6 adaptation layer uh, for some physical and data link layers for the recently standardized IoT protocols. Okay, so that's why this adaptation layer has to be included in the IoT protocols which supports IPv6. Fine. And device implementing technology that requires IPv6 adaptation layer must communicate over an IPv6 only subnet network. That is about IPv6 adaptation layer. So next, optimizing IP for IoT. Like how it is optimized for the IoT. That we'll see under this. So here, internet protocol is a key for successful internet of things, right? Internet of things, maybe it may be constraint nodes or for the constraint networks, right? So mandate optimization at various layers and on multiple protocols of IP architecture. So this image shows an example of IoT protocol stack using the 6 low-pan adaptation layer beside the well-known IP protocol stack for the sorry I mean not for the stack, for adaptation layer, like how adaptation layer IPv6 adaptation layer is included for the IP. I mean how optimizing is done for the IP stack. As you know, at the basic at the lower level, that is physical layer, it is wired or wireless. At the data link layer, it says the accessing technologies, and before moving to the network layer, this adaptation layer has to be included uh, between data link and the network layer, and then comes the transport layer where TCP and IP are followed. Okay, this is about optimizing IP for IoT, or you can see including adaptation layer in the IP stack for the optimization. And next comes the protocol, that is 6 low pan to 6 low. That is, in IP architecture, the transport of IP packets over any given layer, physical layer or the MAC layer, protocol must define and documented. So here the model for packaging IP into lower layer protocol is often referred to as an adaptation layer. Okay, so next, the main examples of the adaptation layer optimized for constraint nodes are the ones under the 6 low pan working group, and its successor is the 6 low working group. So see, for optimizing IP for IoT, we are using this particular protocol, that is 6 low pan to 6 low. Okay, so here it shows that is comparison of IoT protocol stack utilizing 6 low pan and an IP protocol stack. That it says IoT protocol stack. This is IoT protocol stack where you can see what adaptation layer is included. Okay, can see here adaptation layer is included between network and the data link, where the protocol used is low pan. Okay, but this is compared with the what actual IP protocol stack where adaptation layer is not included. Do remember, this adaptation layer is required so that it can work well with IoT. Okay, that is one thing. Next, this is it shows the 6 low pan protocol header stack. Okay, so this shows I mean headers with related to the compression, fragmentation, and the mesh addressing. You can see here, this is with respect to compression, where IPv6 header compression is present between this header and the payload. Okay, and next, with respect to fragmentation, fragmentation header is present between header and the compression. The next, mesh addressing header is included between header and the fragment header. Okay, these are the 6 low pan protocol, that is IP protocol, or the adaptation layer included in the IoT stack with the header given here. Okay, so yeah, that's all. That's what I wanted to complete in this class.